I'm sure everybody knows someone who loves Pokémon, from the games to the anime to the legalized gambling known as the TCG. Pokémon is the biggest media franchise, period. Move over Star Wars and Hello Kitty. Never mind, Pokémon trounces them all. Admittedly, Pokémon was a big part of my childhood. Whilst I never played the games growing up, I loved the anime to death. The Sinnoh League is still the pinnacle tournament arc in my opinion, and the Gen 5 anime gets too much hate. I also had a Pokemon Showdown phase where I was obsessed with making a great team without legendaries, Gengar Hypnosis into Quiver for Corona, and then Sweep. Or if that didn't work, Moxie Salamence or Weakness Policy Metagross. I just realised I haven't gotten to the point. Sorry, I just feel like I need to justify my love for this franchise, as this video seems a bit odd considering the topic of the last few. Today, we're going to be taking a more analytical look at Pokemon and try to quantify what Pokemon stats actually mean. Spoiler, they make no sense. But in this video, I have tried to devise several possible systems to determine what these stats would equate to in the real world. So let's start with how we're going to do this. The most obvious idea that jumped out to me was to just find some Pokedex entries that make reference to specific feats of a Pokemon, reference it with the stat corresponding to that feat, and then work out what one stat point in that trait represents. And it turns out that this is the best way to go. And by best, I mean only. I tried plugging the data into Excel and forming a function, but well, there are just too many outliers to get a strictly increasing function. It doesn't help that the Pokedex, well, it's complete nonsense, like it was written by some 5-year-old. There are plenty of videos covering some of the most nonsensical entries, like Magikarp being able to leap mountains, but being useless in-game, or Tyranitar literally being impervious to physical attacks, which I will not be using to scale these stats, because infinite resistance to physical attack divided by its defense stat of 110, well, that's still infinity. So one stat point in defense is literally infinite, and, well, I think you can see the problem there. To try and do this, I have used several entries for each stat. Furthermore, I use several different kinds of Pokemon. For instance, with speed, I picked some really fast Pokemon, some more average speed Pokemon, and some slower ones. I also did use legendaries, since surprisingly, most legendaries don't break reality with their quantifiable feats at least. There are lots of outliers which are just straight up ignored. I get Pokemon is unrealistic, but using some feats like Gardevoir's miniature black holes for scaling special attack just seems so wrong. Quick new section, called Lanturn will destroy the universe by existing. So, let's be real. Nobody's favourite Pokemon is Lanturn. If it is, you're lying to yourself. But this Pokemon has a dex entry that would put it above Arceus, the literal god of the Pokemon universe. Quote from Fire Red and Leaf Green. The light it emits is so bright that it can illuminate the sea's surface from a depth of over 3 miles. Assume that it's just over 3 miles, like 3.1 miles to lowball as much as possible. There would be approximately 5 kilometers. Now you might be thinking, so what? Well, no. That's just not possible. So, I read this fun paper on light absorbance of seawater, struggled to understand all of it, but I think I got the key points. There's this table. This shows the absorption coefficient of idealized pure seawater per meter at different wavelengths of light. Now, Lanturn's light is clearly yellow, so the corresponding value of absorption is about 8.8% per meter. Also, to try and undersell Lanturn as much as possible, let's say that the light has a power at the surface of 25 watts, a typical light bulb, not illuminating the whole surface of the sea like the Pokedex claims. Anyway, using Lambert's law of absorption and rearranging for the initial power, plugging in our numbers, we get math error. So, the number breaks my calculator. So, I searched up big number calculator online, inputted this, and got a result of 3.07 times 10 to the 192 watts of power. What? Even if we say the light is only 1 milliwatt at the surface, Lanturn's light would still need to have a power output of 1.22 times 10 to the 188 watts. To put that into perspective, the power output of the sun is only 3.84 times 10 to the 26. Lanturn is over 1 times 10 to the 166 times more powerful than our sun. Consider this, the observable universe has an approximate mass of 10 to the 53 kilograms. Using energy mass equivalence, or E equals mc squared, we get the energy equivalent of 1.1 times 10 to the 36 joules of energy. Now compare this to Lanturn. Lanturn, every second releases the energy of 119 universes. Forget vaporizing the ocean. Forget destroying the planet. No, Lanturn destroys everything by existing. So with that mental breakdown out of the way, let's get down to the actual breakdown of the numbers. First, let's start with attack. Attack determines the damage dealt by a Pokemon's physical moves, so we can view it as a blend of striking force, lifting capabilities, and just general physical strength. I know that's a bit vague, but so is the stat. And I mean, if you can lift a lot, it doesn't necessarily mean you can hit like a truck, but let's just say that it all amounts to the same thing. In this line of logic, let's explore some physical strength related entries. From Heracross's Crystal Dex entry, with its Herculean powers, it can easily throw around an object that is 100 times its own weight. So Heracross weighs 54 kilograms, so it can throw around 5.4 tons around like it's nothing. Oh god. But Heracross is one of our stronger examples, so maybe this isn't too much of an outlier. Considering Heracross has an attack stat of 125, 1 point in attack would equate to 43.2 kilograms of lifting strength. To show you the flaw in this Heracross being the sole baseline, that would mean Sunkern with an attack stat of 30 could lift just under 1.3 tons. Something about that seems wrong to me. Compare with a human. The most mass a human has ever lifted, or deadlifted, is 501 kilograms by Hafthor Bjornsson. Now, I don't know Thor personally, but I don't think he would say that it was easy. But to be generous, let's use this feat. Dividing by 43.2, we get an attack stat of 12.5. Weaker than a Sunkern. I don't think it sounds right. So, let's consider some more examples to average it out better. Kingler is another heavyweight in the attack department. Its large pinsler apparently has 10,000 horsepower strength. These units are really killing me. So, 1 horsepower is 746 watts. So, Kingler's Claw has a power output of 7,456,999 watts. Oh no, why horsepower for a crab? The horsepower unit is just completely garbage, layering imperial standards over the uncertainty of a horse's strength. Seriously, why? So, an average car has a horsepower of 200. The most powerful supercars in the world come in 1,300 horsepower. Kingler's Claw is 7.7 times more powerful than the most powerful car engines in the world. This doesn't help us much in quantifying attack. We really need a force, so I'm not going to use Kingler. It just doesn't help in any way, and thinking about it really just hurts my brain. Regigigas, our first legendary, is a behemoth with an attack stat of 160, one of the highest non-mega evolved attack stats. It is said to have towed the continents with immense ropes. Take the Eurasian plate, who has an area of 6.78 times 10 to the 13 meters squared. Now, the thickness of this plate would vary from 100 to 200 kilometers, so let's meet halfway and say it's 150 kilometers, or 150,000 meters. The density of lithospheric material, again, varies between 2,700 to 2,900 kilometers per meter cubed. So, we're again going to take the average and say it's 2,800 kilometers per meter cubed. Plugging all of this into a calculator, we get the mass of the Eurasian tectonic plate to be 2.85 times 10 to the 22 kilograms. So, 2.85 times 10 to the 22 divided by 160 gives us 1.78 times 10 to the 20 kilograms per stat point. Okay, so this is not going to be in the average either. I just wanted to illustrate the ludicrous strength. Perhaps more reasonable than towing continents, but still absurd, is Hariyama. From its Dex entry from Pokémon X, it stomps on the ground to build power. It can send a 10-ton truck flying with a straight-arm punch. Force equals mass times acceleration. Suppose the truck goes from rest to a velocity of 20 meters per second, or 45 miles per hour, in a matter of 1 second. The acceleration is then 20 meters per second squared. So, what 10,000 kilograms multiplied by 20 gives us a force of 22,000 newtons. Oh, sorry, did I say 20,000? I meant 200,000 newtons. Compared to a professional boxer, whose punches can range from 3,500 to 6,000 newtons, Hariyama's punch is about 40 times more powerful than a fist from Tyson in his prime. That is a scary thought. If we take this 200,000 newtons of force and divide by the attack stat of 120, that gives us 1,667 newtons of force per attack stat point. So, a professional boxer would have an attack stat between 2 and 4. Again, this does not seem reasonable, but this is what the dex suggests. Let's stop looking at physical juggernauts and take a look at a more normal Pokemon. Yanmega has an attack stat of 76, but is said to be easily capable of transporting an adult in flight. The wings on its tail help it stay balanced, at least according to its Heart Gold entry. So, the average adult US male weighs about 89 kilograms. In the UK, that mass is a lower 83.6 kilograms, but considering Pokemon up until Gen 5 was inspired primarily by Japan, let's use the average Japanese male. Japan as a country is very conscious of obesity, and as such, the average weight of an adult male is 66 kilograms. So Yanmega can carry anywhere from 66 to 83.6 kg, but showing bias towards the Japanese average, let's call that 70 kg. 70 kg divided by 76 gives us 0.92 kg per stat point. Now, that seems reasonable. If Yanmega were our metric, an average adult would have an attack stat hovering between 50 and 80. Computing Thor's max deadlift on a world record bench press would of course give ludicrous stats over 450, but they do not really apply to this situation as they are far from easy, so 0.92 kg per attack seems reasonable. Let's take a look at one of the most strange looking Pokemon, Gerda. Gerda carries around with it a steel beam. How it gets this when it evolves from Timber is a mystery that may never be solved. Gerda itself is 1.2 meters tall, but its beam is slightly longer. I'd say about 1.4 meters. If we say it is 0.2 meters thick and wide, then the volume of this beam is 0.056 meters cubed. The density of steel varies between 7,750 to 8,050 kilograms per meter cubed, so the mass of this beam ranges from 434 kilograms to 451 kilograms. But hold on, Gerda's beam is not just one solid cuboid. As you can see, there are gaps, so this calculation is overblown. Supposing the middle section has a width of 15 millimeters, or 0.015 meters, then the cuboids either side of it would have a length of about 0.0925 meters each. If we combine them into one of calculation, then 0.185 squared multiplied by 1.4 gives us a volume of 0.0479 meters cubed. Multiplying this by the density of steel and subtracting from our original value, we get a more reasonable weight range of 62.6 kg and 65.5 kg. This is still super impressive, and the ease at which Gerda swings this thing around is superhuman, but if we compute this value by dividing Gerda's attack stat, we get a lower value than Yanmega's baseline. We get 0.62 kg per stat point. So that was a wide range of Pokemon to use for attack metrics. So if we were trying to average them all out, ignoring Regigigas, for obvious reasons, we get that one attack point would represent the ability to lift 15 kilograms. Maybe averages aren't such a good idea. Blame Heracross. So, for all my effort, every dex entry that mentions strength is either ridiculously high, like Machamp moving mountains with one arm, or non-existent, as Pokemon without super high attack stats don't get entries focused on their attack. Go figure. This raises the question, who is to say it's a linear relationship? What if it were like a logarithmic scale? Like decibels? That would make sense as to why it tends to infinity when the attack stats get really high. But again, I couldn't define a function for it because all the attack stats are so inconsistent. Sorry, I'll calm down. I'll calm down. It's only gonna get worse from here. I can't be getting angry already. Still got all the other stats to go. Okay. The next stat is defense. If we take defense to be their ability to withstand physical damage, then we look at dex entries that focus on a Pokemon's durability. Take Chestnut. According to its Y dex entry, when it takes a defensive posture with its fist guarding its face, it could withstand the Bomb Blast. Now, Bomb Blast is not very specific. Thanks a lot, Pokedex. But let's consider a few possibilities. TNT equivalence is often used to compare the explosive damage caused by different sources. Essentially, how much TNT would be needed to reproduce the same explosion. 1 kilogram of TNT produces an overpressure of of 230 kilopascals and producing a blast wind of 240 kilometers per hour. Measured from the origin of the blast, the overpressure is probably more commonly known as the blast wave and is caused by the initial release of energy responsible for the explosion. The bigger the explosion, the more damaging the pressure wave. There are several facets to an explosion that make it lethal. The rapid release of energy causes a shockwave that can compress your body, rupturing organs, causing veins and even your eyes to burst. Then, considering the heat of the air and the high-speed shrapnel, and it's clear to see the lethality. The human eardrum may be ruptured at only 35 kilopascals. When the overpressure reaches 100 kilopascals, all eardrums will be ruptured or even destroyed. Of course, this is based on a range, but take a look at this table. Looking at the 20 psi or 138 kilopascal row, this kind of explosion can easily destroy concrete and collapse buildings, so us humans stand no chance. I focus on metrics like pressure and wind speed because that is why an explosion causes damage, the rapid release of energy. Chocolate stores more calories or energy per unit mass than TNT, but it does not cause explosions as the release of energy is nowhere near as rapid. Anything over 50 psi results in death. So if Chestnut is as durable as the Pokedex claims, it can easily withstand overpressures of 90 psi. In terms of energy, 1 kg of TNT releases 4.18 megajoules of energy. Taking this low ball first, 4.18 times 10 to the 6 divided by a defense stat of 122 gives us 34,262 joules per defense point. That amounts to 8.2 grams of TNT per defense stat point. Admittedly, this is not the most logical way of doing this. As I said, energy is not the cause of death. So examining the overpressure, 90 psi equates to 620 kilopascals. Dividing this by 122, we get one defense point is equivalent to 5.1 kilopascals. If we use this, then the average human can withstand 35 psi or 242 kilopascals, thus would have a defense stat of 48. Another thing we could consider is density and hardness. How tough is a Pokemon's skin? Take Devise, a Pokemon who is clearly made out of diamonds, so it follows that its skin has the same hardness and density as diamond. Well, diamond has a density of 3,520 kilograms per meter cubed, and Devise has a defense stat of 150. Thus, 1 point of defense correlates to a density of 23.5 kilograms per meter cubed. Humans have a density of about 985 kilograms per meter cubed. This would make sense intuitively. Water has a density of 1,000 kilograms per meter cubed, so the specific gravity of a person would be 0.985, or in other words, 1.5% of our body floats above the surface of water naturally, since we are less dense. Assuming the average human has a body mass of 70 kg, then the volume of a human being is 0.071 cubic meters. That doesn't really contribute to the defense stat, however just something interesting. If we use Devise as a baseline for defense, a human would have a defense stat of 42, and now that also seems quite reasonable. Let's look at Registeel next. It, like Devise, has the defense stat of 150. From its Ruby entry, Registeel has a body that is harder than any kind of metal. Its body is apparently hollow. No one has any kind of idea what this Pokemon eats. And from its Emerald entry, its body is harder than any other kind of metal. The body metal is composed of a mysterious substance. Not only is it hard, it shrinks and stretches flexibly. So we have a fictional metal that does everything. What I'm going to do is composite the best properties from a bunch of real-world metals and alloys and increase them by about 40% to make Registeel's body more fictional than imaginable. Unsurprisingly, steel is one of the hardest materials, which certain alloys have a tensile strength of 1,600 megapascals and a yield strength of up to 1,560 megapascals. Tensile strength means how much the material resists being stretched/pulled apart. For instance, Play-Doh has a relatively low tensile strength compared to wood. Yield strength means how much material resists plastic deformation or permanent change in shape. This can be viewed as a traditional hardness. Now, Obviously steel is not a natural metal, it's an alloy made by humans. But come on, it's literally named Registeel. If you're craving a natural metal, however, tungsten and titanium are probably the best bets, as they're the hardest in real life. Tungsten has an impressive tensile strength and ultimate tensile strength of 1510 megapascals. Tungsten is often considered the hardest natural metal on Earth. But hardness has many facets, and tungsten is not as useful in some contexts due to its brittleness. Titanium may have lower stats, but its low density makes it more practical a lot of the time. Boosting the numbers, Registeel could have a yield strength of 2148 and a tensile strength of 2224 megapascals. Doing the maths, one stat point in defense would equate to 14 megapascals of yield strength and 15 megapascals of tensile strength. Human bone has a tensile strength of 114 megapascals, which would equate to a defense stat of 7.6. This seems low compared to all our other values, and what's worse is that we are being very generous, since we obviously aren't just made of bone, but we have soft squishy parts as well. Perhaps I didn't boost Registeel's numbers enough, or perhaps I boosted them a bit too much. Feel free to make your own modifications. I would like to say though that my methods are far from perfect, and I hope I do inspire you to do your own calculations. Defense-related entries were hard to come by for non-rock or non-steel Pokemon, so here's another steel type. From Metang's Fire Red and Leaf Green entry, its body is so tough even a crash with a jet plane won't leave a scratch. That is absurd. Let's say that is a private jet, which typically travel at speeds of 900 km per hour, or around 250 meters per second. An average weight may be around 14,000 kilograms. So, a jet like that would have a kinetic energy of 437,500,000, or 4.375 times 10 to the 8 joules of kinetic energy. It would also have a momentum of 3,500,000 kilograms meters per second. Since force is the rate of change of momentum, and assuming the impact lasted 1 second, the force exerted on a Metang during this collision is 3,500,000 newtons of force. The momentum transfer is what causes the damage. Since Metang has a defense stat of 100, one stat point represents 35,000 newtons of force, or the ability to withstand the momentum change of 35,000 kilogram meters per second. The average human can't withstand anything over 9 Gs, or 88.29 newtons per kg of body weight. On a 70 kg person, 1 G represents 686.7 newtons. So, 9 Gs translates to 6,180.3 newtons per second, or experiencing a force of 9 times your own weight. Then we get a defense stat of less than 1. So, no. For reference, 4,000 newtons of force is required to break the femur bone. 35,000 is enough to leave you a bloody mess. To conclude this section, I'd like to discuss something I found quite funny. So, Steelix is supposedly harder than Diamond, which makes sense, as it has a defense stat around 200. But apparently, Shelder's shell is impervious to attack, and is also harder than Diamond, though Shelder only has a defense stat of 100. So is Steelix twice as hard as Shelder, or is this more evidence that the dex is nonsense? And then this also contradicts Diancie and Registeel, who have defense stats of 150, and one is Diamond, whilst the other is a super hard fictional metal. This is just a mess. So let's just move on to speed. Speed might seem like the easiest to define, and, well, it is. It's just how fast a Pokemon can travel. I was initially curious about things like speed in combat versus reaction speed versus ground speed versus flight speed versus water speed, since all are relevant to Pokemon, but I think the speed stat represents its maximum speed through a particular medium of choice, be it land, sea, or air. Using this definition, let's look at some dex entries. When I think of fast Pokemon, I think of Rapidash. I mean, its name is literally Rapid Dash. I mean, it must be fast. Rapidash has a speed stat of 105, which seems too low, considering that other Pokemon that don't have nearly as much emphasis placed on their speed can have stats upwards of 115. Anyways, every Pokedex entry cites its top speed as 150 miles per hour, or 67 meters per second. Hence, one speed stat represents the ability to travel 1.4 miles per hour, or 0.64 meters per second. Usain Bolt holds the record for the fastest 100-meter sprint, completing the whole thing in 9.58 seconds. Thus, his average speed over that period was 23.4 miles per hour, or 10.4 meters per second. However, his top speed was during the 60 to 80 meter stretch, where he reached 12.4 meters per second, or 27.8 miles per hour. Now, assumedly, Rapidash can last at this speed for longer than 100 meters, but for the sake of making humanity look somewhat better, let's take Usain Bolt's top speed for those 20 meters as the peak human speed stat, and not factor in its unsustainability. Humans would have a speed stat between 19 and 20. Ouch. For reference, Pineco, a literal pine cone, has a speed stat of 15. How can it even move? This thing can outrun most people on the planet without legs. Sticking with Gen 1, let's talk about Dodrio and Doduo. These Pokemon are interesting because whilst Dodrio is the evolved form, Doduo has a better dex entry for its speed. From Dodrio's yellow entry, it runs close to 40 miles per hour in prairies, whereas Doduo's crystal entry claims it lives on grassy plain where it can see a long way. If it sees an enemy, it runs away at 60 miles per hour. Now, I suppose one represents a casual running speed, and one represents a maximum speed, boosted by adrenaline. So, I suppose Dodrio could run at a speed of 60 miles per hour. Or, since Doduo is lighter, it can achieve a greater speed. That seems unlikely though, as this is Pokemon, and evolutions don't get slower stat-wise. At least normally. There are some examples like Scizor from Cypher, but that is due to a massive shift in weight. So, taking Doduo's speed of 60 miles per hour, or just under 27 meters per second, and then combining this with the speed stat of 75, we get that one stat point equates to 0.36 meters per second, or 0.8 miles per hour. That is surprisingly close to Rapidash's baseline. I mean, for this video at least. If we use the Rapidash system, Doduo would have a speed stat of 43, but I mean, it is close for the Pokedex. And again, it may be an exponential increase or something like that. If we use Dodrio's speed of 110, and say that its top speed is also 60 miles per hour, we get 0.55 miles per hour, or 0.25 meters per second per speed stat point. Under the Doduo system, humans would have a peak speed stat of 34, and under the Dodrio system, we would have a peak speed stat of just under 50. Oh my god, yes! Yes, I finally got it. I've been saying that sentence for the past 20 minutes now? So, yeah, I'm leaving this in. I'm not doing that again. You get to hear my excitement. It's not in the script. Anyway, where was I? Oh yeah, we would have a peak speed stat of just under 50. Take that, Pineco. That seems more reasonable. But if any Pokemon can usher us into the realm of contradictory insanity, it is our good friend, Metang. From its Emerald entry, the claws tipping its arm pack the destructive power to tear through thick iron sheets as if they were silk. It flies at over 60 miles per hour. I'm going to ignore the attacking one for my sanity, since it only has an attack stat of 75. Its speed stat is even more of a mismatch. It has a speed stat of 50, the same as a human under the Dodrio system. We just established that 60 miles per hour equates to 75 or 110 stat points. Now, if we use the Metang speed metric, one stat in speed means 1.2 miles per hour, or 0.54 meters per second. Actually, that is closer than to Rapidash's basis, and still not too absurd. Maybe I was too harsh on Matang. Anyway, using this, a human would have a speed stat of 23. Still beating a pinecope, so fine by me. So, okay, speed seems to be making sense. Good job, Pokedex writers. The speed-related entries seem to scale nicely to the speed stats. But if there's one way to descend into madness, it is a legendary. Take Zeraora, with a speed stat of 143. Its sword entry claims it runs as fast as lightning strikes, shredding its opponents with its high-voltage claws. Oh no. So, lightning is fast. Obviously. Light is also very fast, and I did a whole other video on how we measure the speed of light. But, TLDR, we can't measure the speed of light directly. So, Zeraora's speed stat of 143, under my favourite Dodrio system, equates to 36 meters per second, or 79 miles per hour. Under the more extreme Rapidash system, Zeraora's speed stat would translate to 91.5 meters per second, or 200 miles per hour. Big range of speeds there, and all very fast for any animal. The fastest known land animal is the cheetah, with a max speed of 70 miles per hour. So, in the most realistic circumstances, Zeraora is 9 miles per hour faster than a cheetah, or in the most extreme circumstances so far, Zeraora is outrunning reckless drivers on the motorway. But that is based on previous scaling. If we take this dex entry and stat in isolation, we break the dex's consistent streak. Lightning travels at 270,000 miles per hour. The light from the strike travels at the speed of light, obviously, but the time for the bolt to strike the ground is slower. The speed of the actual strike is 120,071 meters per second, which is rather tame compared to the speed of light, 3 times 10 to the 8 meters per second. For reference, it would take a lightning bolt 53 minutes to reach the moon, whereas it would take light 1.28 seconds. So now I've shown you that the speed of lightning is reasonably slow compared to light. Let me show you why the speed of lightning is still absolutely insane. The fastest jet in the world, the Lockheed SR-71 Blackbird, travelled at 3,500 kilometers per hour, or 1,972 meters per second. Lightning, and thus Zeraora, is 123.5 times faster. No. No. It would melt and explode and just cease existing. A living organism couldn't travel that fast. But if we use this as our basis, we get that one speed stat represents 840 meters per second, or 1,888 miles per hour. So, not only would us humans, but retroactively, most Pokémon would have speed stats less than 1. Rapidash, for instance, would have a speed stat of 0.08. Now that would be a very fun game. Ninjask is the second fastest Pokémon, just 20 stat points below Deoxys' speed form. From its Ruby Dex entry, Ninjask moves around at such high speeds that it cannot be seen, even while its crying can clearly be heard. For that reason, this Pokémon was long believed to be invisible. Oh no. How does that make sense? The light from Ninjask should travel faster than the sound. But this does let us do a fun, albeit nonsensical calculation. Okay, so let's imagine a 100 by 100 meter field. Our human field of vision spans around a 200-degree arc. Our binocular vision, the amount in front of you, both your left and right eyes can perceive, is 120 degrees. So, at any one time, if Ninjask were to be invisible, it would have to move so fast that our brains wouldn't have enough time to process the light reflecting off it. A 2014 MIT study suggests our brains can process an image seen by our eyes for only 13 milliseconds. From our field of vision, we can only perceive about 90 meters of the field at a time. Thus, for Ninjask to be invisible, it would need to cross a 90-meter distance in 13 milliseconds. That translates to a speed of 6,923 meters per second, or 15,486 miles per hour. That's over 20 times faster than the speed of sound. Ninjask, a bug, would be burnt to a crisp. This calculation is very flawed, however. This is because I am assuming that Ninjask is moving back and forth, horizontally, over that specific 100-meter field. This is just the lowest potential speed. Theoretically, Ninjask could be faster than the speed of light, since it moves distances faster than the light reflecting off of it. But that is just going to give us an incomprehensibly large number. If we use this lowball, one stat point would correlate to 43.3 meters per second, or 96.8 miles per hour. Now, obviously, that is still ludicrous, but not as crazy as Zeraora. Humans would still have a speed stat less than 1, as would most Pokemon. Rapidash would have a speed stat of 1.5. So this seems a bit absurd. Again, pointing to an exponential form of speed increase. Or more likely, the fact that no one cares, but there's no internal consistency between a Pokemon's Dex entries and the Pokemon's actual speed stats. I mean, I said more likely. I'll let you decide, but, I think it's obvious which one is correct. Now, I would like to discuss Mach speeds, and how the Pokedex doesn't understand what Mach speed means. According to Pidgeot's Yellow Dex entry, this Pokemon flies at Mach 2 speed, seeking prey. Its large talons are feared as wicked weapons. Pidgeot would be flying at speeds of 1,534 miles per hour, or 686 meters per second. Pidgeot has a speed stat of 101, so one stat point correlates to 6.8 meters per second, or 15.2 miles per hour. This obviously conflicts with our previous basis, especially considering that Rapidash is faster stat-wise, but has the slowest top speed. Perhaps airspeed and ground speed have different metrics for a high speed stat. Another Pokemon who can achieve Mach speeds is Garchomp, with a speed stat of 102, which aligns with Pidgeot. From its Pearl entry, it flies at speeds equal to a jet fighter plane. It never allows its prey to escape. So, that makes sense. The speed stats are close, and both these speeds are presumably related to speed in flight. Thus, they are close. Ignoring the fact Garchomp can't learn fly. You want to know another Pokemon who can achieve Mach speeds? Golurk. From Pokemon Black, it flies across the sky at Mach speeds. Removing the seal on its chest makes its internal energy go out of control. Golurk has a speed stat of 55. What? No. Mach what? Mach 0.01? I just assume that the speed stat correlates to its ground speed, but why? Surely it should correlate to its fastest speed. Perhaps Golurk is mostly on the ground, but then so is Garchomp. This just seems so arbitrary, almost as if there was no thought put into these. Frogadier, according to its Y entry, its swiftness is unparalleled. It can scale a tower of more than 2,000 feet in a minute's time. Great. Now we have climbing speed. Does this speed reflect its speed stat of 97, or does it not factor in at all? Computing this as a separate thing, Frogadier can climb 609.6 meters in 60 seconds, meaning it climbs at a rate of 10.2 meters per second, or 22.8 miles per hour. One speed stat point represents 0.1 meters per second, or 0.24 miles per hour of climbing speed. Skilled human climbers can achieve climbing speeds of 2.75 meters per second, so would have a climbing speed stat of 27.5. That seems reasonable. We aren't the most adept climbers, but we are quite good. Or at least, some of our species are. Sticking with Gen 6, Talonflame, according to its Y entry, when attacking prey, it can reach speeds of up to 310 miles per hour. It finishes its prey off with a quick, colossal kick. Talonflame has a speed stat of 126, so faster than Pidgeot, Garchomp, and definitely Golurk. Yet its top speed doesn't even break the sound barrier, so one stat point represents 2.5 miles per hour or 1.1 meters per second, meaning a human would have a speed stat of 11. I mean, we would, if we could fly. Which we can't, to my knowledge. To conclude our speed section, let's circle back to Gen 1, with Dragonite. According to Pokemon Emerald, it can circle the globe in just 16 hours. It is a kind-hearted Pokemon that leads lost and foundering ships in a storm to the safety of land. The circumference of the Earth is 40,075 kilometers. Doing some simple maths, 40,075 times 10 to the 3 divided by 16 multiplied by 3,600 equates to 696 meters per second, or 1,556 miles per hour. Dragonite has a speed stat of 80, yet is faster than Pidgeot, with a speed stat of 110. So one speed stat point correlates to 8.7 meters per second, or 19.5 miles per hour. We have used the human metric so much, how about we use something different? Let's give a plane a speed stat. A Boeing 747 has a speed of 565 miles per hour, so we'll have a speed stat of 29. So, if Pokemon ever makes a plane Pokemon, its speed stat better be 29, even if it is slow in the game. Now we are getting to the hard ones. First, let's establish something. Magic isn't real. I'm sorry. But we can't shoot elemental powers out of our fingertips. From this view, a human would have just a special attack stat of 0. But if we look at what makes a move special, we see things like Thunderbolt, Flamethrower, Hydro Pump, and Hurricane. These are things that have real-world equivalents, some natural phenomenon, some technology-based. More vaguely, special attacks are anything that is not physical, the idea of mana manipulation. That is what separates a hurricane from an earthquake in the physical special split. Another view of the special attack stat could be intelligence, as often intelligent Pokemon are correlated with high special attack stats. I'll be considering both these points of view. Let's start with Game Freak's favourite Pokemon, Charizard. According to the Pokemon Shield Dex entry, the flame inside its body burns hotter than 3,600 degrees Fahrenheit. When Charizard roars, that temperature climbs even higher. This correlates to 1,982 degrees Celsius. Assuming that when Charizard uses an attack like Flamethrower, that the flames it emits have this same temperature, then we can use this. Humans have an internal body temperature of 37 degrees Celsius. Using the Stefan Boltzmann law and modelling both humans and Charizard as black body radiators, we can determine Charizard's thermal output. So, from this equation, the only thing we are missing is the area. To calculate the surface area for Charizard was not an easy task without having access to the 3D models, but I will try my best. Charizard is 1.7 meters tall and has a mass of 90.5 kilograms. I use super high-tech software, PowerPoint, to measure out a few lengths and convert them using the height of 1.7 meters. Charizard has a wingspan of 1.995 meters and a body width of 82.2 centimeters, so I used a few different shapes to model the surface area of a Charizard, and got a rough estimate for the surface area as being 7.29 meters squared. Plugging this into the equation, we get a power output of 10,688,000 watts. Since Charizard has a special attack stat of 109, this means that special attack equates to 98,055 watts per stat point. Doing the same calculations, but instead with a human, we get the power output of 995 watts. So, yeah, we would have a special attack stat of 0.01. Lugia has a special attack stat of 154. From Ruby, Lugia's wings pack devastating power. A light fluttering of its wings can blow apart regular houses. As a result, this Pokemon chooses to live out of sight deep under the sea. Lugia is a Pokemon that can use Hurricane, and from this entry, we can see that makes sense. From the fact its wings can generate winds that blow apart houses, it is safe to say that the wind speed is 160 miles per hour or more. That would be a Type 5 Hurricane. Dividing the wind speed by 90 gives 0.79 meters per second or 1.78 miles per hour wind speeds per stat point. Sneezes have a maximum velocity of 4.5 meters per second, or 10 miles per hour, thus we have a special attack stat of 5.7. This is similar to a forceful cough, so we are doing better. 5.7 is better than 0.01. So sneezing is our most powerful special attack. Keep that in mind. It might come in handy if you are ever unable to run away from a fight. Famously, Alakazam has an IQ of 5,000, which many have discussed is absolutely absurd. Alakazam has a special attack of 135. Thus, using the idea of intelligence equating to special attack, one stat point equals an IQ of 37. Thus, the average human has a special attack stat of 2.7, considering the average IQ is 100. The highest recorded IQ in human history is contentious, but I'm going to take it as 198, belonging to Evangelos Katisoulis. He would have a whopping special attack stat of 5.4. Of course, IQ is not a good metric of actual intelligence, but rather a metric of how good you are at taking IQ tests. Metagross is also stated to be more intelligent than a supercomputer. What exactly does that mean? Well, we could consider processing speed. The processing speed of the fastest supercomputer in the world is 442,010 teraflops per second, or 442 petaflops per second. This speed was achieved by Japanese teams Raikkonen and Fujitsu, who developed the Fugaku supercomputer. It can conduct 442 quadrillion calculations per second. Since Metagross has a special attack stat of 95, one special attack point represents 4.7 petaflops per second. Now, these sound like massive numbers, but consider the following. By comparison, the human brain operates at an estimated 1 exaflop, or 1 times 10 to the 18 flops per second. That equates to 1 billion calculations per second. So a human would have a special attack stat of 213, which would have the highest special attack in the game. Now, there are lots of issues with comparing supercomputers to the human brain in terms of intelligence. This is because the brain's calculations are quite random and unpredictable, whereas every calculation a supercomputer completes is very specific and relevant to the task required. The human brain and a supercomputer are not comparable, but I like the idea that humans have high special attack stats. That explains why Pokémon trainers can control their Pokémon. They are simply more intelligent. It may also explain why Mewtwo is able to talk. Its high special attack stat is putting it closer to the human intellect. And then, I guess by proxy, that means Meowth from the anime is also some uber genius. By Pokemon standards, I mean. Moving on to special defense, we can use the same principle as special attack, but in reverse. How much can a human resist things like high temperatures, winds, etc.? From Regice's Sapphire entry, Regice cloaks itself with frigid air of negative 328 degrees Fahrenheit. Things will freeze solid just by going near this Pokemon. Its body is so cold, it will not melt even if it's immersed in magma. Magma has a temperature range of 700 to 1300 degrees Celsius. Since Regice has a special defense of 200, one stat point would be the ability to resist anywhere from 3.5 to 6.5 degrees Celsius. Now, humans can survive in a range of different temperatures, dependent on the humidity of the air. The maximum body temperature a human body could survive is 42.5 degrees. Thus, a human would have a special defense stat between 6.5 and 12. Above 42.5 degrees in the human body, proteins get denatured and the brain suffers irreparable damage. However, if we consider dry air, not the internal body temperature, most humans die of hypothermia at 60 degrees. So that would correlate to a special defense stat between 9.2 and 17.1. Now let's go back to the Lugia system. One special attack point represents wind speeds of 0.58 meters per second or 1.3 miles per hour. Since special defense represents the ability to resist special attacks, then one special defense point should represent the ability to resist 0.79 meters per second or 1.3 miles per hour wind. The average person can be moved by 67 miles per hour or 30 meters per second wind. This would be enough to move a 70 kg person, but a higher wind speed would be required to blow someone over. So let's say 75 miles per hour or 33.5 meters per second is the threshold for resistance. Thus, a human can have a special defense of 42, the meaning of the universe. HP is the final and perhaps most abstract. I looked through Pokemon with the highest HP stats and tried to find the correlation. They tend to be very large, or have thick skin, or have a high body fat percentage. So those are our potential metrics. Now let's consider them. First is size. We should pick a Pokemon with a comparable size to a human that would allow us to assign a HP value to a human. Incineroar and Blaziken seem like good examples of humanoid builds. Blaziken has a HP of 80, and Incineroar has a HP of 95. Both are quite muscular, but Incineroar much more so. So Incineroar is bulkier and has a higher HP. From this, a human could be measured to have a HP between 60 to 100, since there are definitely bodybuilders, natural or not, with much bigger builds than Incineroar. This doesn't help us get to a per point ratio, so we could consider the heights, but that also seems quite flawed. Consider Snorlax, who has an HP of 160. Snorlax has a mass of 460 kilograms. Let's take the mass and divide it by 160 to get 2.9 kg per hit point. This seems much better, as there's a greater correlation between the mass and the HP of a Pokemon. So, now the average mass of an adult male is 70 kilograms, thus a human would have a HP of 24. Another idea I mentioned is body fat. Hariyama is clearly based on a sumo wrestler. Sumo wrestlers have a body fat of 26.2%, so, based on Hariyama's HP of 144, we get 0.18% body fat per hit point. Average body fat of an adult male is 20%, thus the average male would have a HP stat of 111. This metric has the issue that the leaner you are, the less HP you would have. Someone could be a mass of muscle, but have a much lower HP. But that does it for this video. The last thing I want to do is total up the stat points for the average human and see how good they'd be. I'm going to be a bit biased to make the human somewhat viable. So, humans, under the most biased conditions, have a HP of 111, an attack of 80, defense of 42, special attack of 213, special defense of 42, and a speed of 50. These lead to a stat total of 520, which is more than average. It's quite high, actually. Very good special attacker, but very frail and very slow, so probably unviable. Again, this is being the most generous we can be to humanity. If we use some of the other metrics, or try to average them out, which is near impossible due to the outliers and the vast range between them, a human may end up being weaker than a sun kern. But, with that said, thank you for watching this long video.